Good afternoon. So we're going to learn another chi-square test now. It is nowhere near related to the goodness of fit test. The only thing that has in common is exactly the way we found it is going to be exactly the same. Observed minus expected squared divided by expected added up. That's the only thing they have in common. That's the only thing they have in common. The degrees of freedom will be different later on. And how we go about finding the expected values is going to be different. So what we're going to start off with, this is called a chi-square test for independence. Independence. And the idea here is that you have a couple, two that is, of categorical variables. For instance, eye color and, well, I don't know, gender, I guess, because why not? Does it matter what gender you are on your eyes? No, probably not. At least I never thought it did. So if that were the case, I mean, what would you expect? Well, I don't know what I expect, but I do know going in that I can go out and collect some data. And so here's my blue eyes, and I saw 70 and 65, whatever. And here's my green eyes, and for them I saw 60 and 61. And for the hazel, I saw, I don't know, 20 and 15, sure. And for the brown eyes, and I'm going to assume this is only the kind of eyes I can find out there. And maybe somebody else will say, well, I have multicolor, and I have red eyes. You should get those fixed. But I don't really know other than that. Right? Now, notice that there were 135 blue-eyed folk. There were 121 green. There were 35 hazel and 165 brown eyes. There were 150, 230 men. And, oh, geez, there's 100, 161, 226, I think, women. Should be a grand total of 456 if I didn't screw it up. Okay? Now, you'll notice that it was almost exactly 50-50 men and women here, yes? Almost exactly. Well, Jay, could you get your calculator out and tell us exactly what percentage? I suppose I could. Come on, make it bigger, you hippie. No, don't move it. I said make it bigger. There you go. Jesus Christ. All right. So, assuming that all that other stuff is right, I can add. Who knows, right? So 230 divided by 456 comes out to be roughly 50.4% men. And of course, that's going to give me like 0.496 women. So it's just about 50-50. Okay? So then the question would be, of the 135 people with blue eyes, what percent should be boys? Well, I feel like it'd be 0.5 times 135, yes? And so basically, what does that say? I can't read that. 68. In other words, I would expect basically 68 blue-eyed people. That means the other 67 would have been women, yes? Because these also must add to 135. And then of the 121, I would have got 60.9. And of course, then this would have been like 60.1, I suppose, because it has to, again, add up to 121. And so on and so on and so on, all the way across. So the only difference is how we're going to find those expected values. Now, your book makes a huge deal. They say, let's take the row marginals, and they do something like row sub I totals or whatever. It's not important, but they take the row total times the column total, right? And then divide it out by the grand mean, or the grand total, I should say. So the row total times, row total times the column total. How come it works sometimes and it never works when you want it to? The row total times the column total divided by the grand total. That's how the book describes it. So for this one right here, I would take this column that it's in times its row that it's in divided by this guy. I find that beyond obnoxious to try to explain it to kids why that is. I prefer to think of it this way. If 50% of all the people are men, 50.4%, then 50% of the blue-eyed people ought to be men, 50% of the green eyes, 50% of the hazel, and 50% of the brown. And if there's just boys and girls over here, then the other 49.6% ought to be, women. If that's true, that in fact there's no difference due to gender. Okay, in other words, that they're independent. Okay, if that's true, that should be true. Now, so when we go into this, our H naught is always, in this case, it's going to be gender and I color are independent. Now I'm going to write it like that at first. Now, if you're going to say otherwise, you're not going to say gender is independent of eye color, because that suggests that if my eyes turn green, I'm going to change genders, and that's weird. If you're going to say it one way or the other, you're going to say eye color is independent of gender. But I don't care. You can also say gender and eye color are independent. Of course, the opposite of that is that they are dependent, or they are not independent. I don't care. You can say it either way you want to. So there's a better way to do this, in my opinion, and that is to use Excel. Okay? So I'm going to go ahead and input my data, and then I'm going to show you how I go about, finding, I'm going to show you how I go about finding my expected values in a quicker manner that I hope you'll like. To me, it's just the only way to fly. I mean, wow, it is awesome. Because if you dink around having to do this by hand, and then you get a really long calculation, and then you're just dying inside. You're like, why is this taking so long? Well, I have better things to do. I could be, I don't know, cleaning public urinals with my own toothbrush or something really fun, I mean, it's ridiculous. So, somebody asked me once if I'd ever consider teaching junior high. I said, no, I'd sooner clean public urinals with my own toothbrush, and they thought that was pretty funny. But yeah, it's, no offense, I guess they're fine. It's too much for me. I like what I teach at the high school. So here I could do equals sum, and I can get this row total here. You see that? Boom. And then I can drag it down. And then down here I can go equals sum of these guys, and then drag it across to right here. Yes. Okay. And that's pretty easy to do. And then I'm just going to copy this table like this. I'm going to copy it for a second, and then I'm going to show you what I want to do. I'm going to grab these numbers inside. I'm going to get rid of them. Okay, I'm just going to get rid of them. And, well, I'm just going to clear. Actually, I'm going to get rid of all of it. That's fine. It's not important to me. Right click it, clear contents. Alright, here we go. So what I'm going to do for the blues, I'm going to say equals. Now remember, it's this column total. Now I want that sucker to stay in column B. Or I'm sorry, in row 4. I want to stay in row 4. So the way to get that to happen is this. If you hit your F4 key on your computer, you get it to there. If you hit F4 once, you get $2. Hit it again, you get this guy. Hit it again, you get that guy. Hit it again, you get back to normal. So 1, 2, that's where I want. What that does, the $sign in front of the number, means that no matter what I do in a minute, when I start dragging this formula around, it's going to keep it in row 4. But it's going to let it move side to side because I don't have a $sign in front of the B. Times this guy here, but I want him to stay in column F. So I'm going to make it look like that. I hit F4 3 times. and then divide out by this guy and hit F4 just the one time. The button F4 on my calculator, on the computer. Okay. Now when I do that, I can click and drag down and then click and drag over. And you know you're right, because if you click just one of these random guys, you'll notice what I got. I've got the column for Hazel along with the row for Hazel divided by the grand total, and that is correct. So what I'm going to do is I'm just going to go equals this guy, parentheses, this guy minus this guy squared. So that's, these are my observes, these are my expecteds, divided by my expected value. Click and drag it down, click and drag it over. And then, here's the best part, equals sum, and we're done. And this right here is my chi-squared value. That's my chi-square value right there. Boom. And so we need degrees of freedom. So the degrees of freedom for this guy, this test, is pretty cool. It's pretty easy to do. It is just row minus 1. So how many rows did you have? Minus 1. Times how many columns did you have? Minus 1. Well, we had 2 genders, so we had 1. 2 minus 1 is 1. Times, and then we had 4 eye colors. Is that right? Yes, sirree, Bob. So we had 3 degrees of freedom. Okay. So I can do this a number of ways, but in my opinion, it's the easiest way because it is just an upper tail test to go equals chi-square. Oops, 1 minus chi-square just. Oops. Of this guy, comma 3 degrees of freedom, comma 1. And so I get a 79% p-value. Well, if this is my p-value, I didn't even ask you, I don't think this time, about an alpha yet, but obviously that's bigger than 0.1, which is the biggest alpha we'd ever use. So our decision is to what? Was to fail to reject H0. And by failing to reject, well, what was H0? Gender and eye color are independent. So we're going to run with that. Gender is independent, or eye color is independent of gender. And that's pretty sweet. Now, out here on my, if I can find it, I don't see it. Let me pull up a set of data. This is data that I have concocted. Now, your book will always have a table like this set up. And that's great. There's nothing wrong with that. It's certainly easily done. But I want to show you what it will actually look like in the real world more often than not. And yeah, it's just a fun little deal. So pivot table. Here's the pivot table, I think. Oops, not that one. This one. There we go. Nice, nice, huh? Look at that. What a freaking mess. So let's look at this thing here. I got 200 data points. Awesome. So there will be an assignment on how to use pivot tables coming up. You'll get to use them for this section. It's going to be kind of fun. And so, boom. Here we go. So what I might want to know is brand of car rather, independent of ice cream type is car brand independent of ice cream. By the way, most of you would say, well, of course it is. Well, who would think it wouldn't be? Well, now wait a minute. No one said that there was any cause and effect relationship. In fact, where I grew up, there were, when you went, you go back there, and then where I taught my first couple of years in teaching up in Idaho, there was pockets around where people only drove John Deere, or they only drove International, or they only used Gleaner combines, or they only had Ford trucks. And you're like, what is the deal? Well, here's why. It's because in certain areas there were only certain dealers. And you're not going to travel 60, 80 miles to get parts, for crying out loud. So would it make sense to buy a tractor or a combine or whatever that if you need parts for, which you always are going to need parts, you don't have time to be running 60 miles or whatever to get parts. So you want to buy something that you can have serviced nearby. It only makes sense. And so if someone said to you, "Well, does it matter where these people, is the brand of combine independent of location?" And a lot of people would say, well, "Sure it is." It's not usually, because it has to do with, well, what car company or what truck company or what combine dealer is in the area that you're going to deal with. Okay, especially in the older days, because you had older trucks. They didn't go very fast. You're not going to want to run 60, 80 miles to get parts, for goodness sakes. 8, 10 miles. Okay, that's one thing, but not that far. And it's just these same things. And here's an interesting one. Also, do you think that it matters what kind of tractor you drive? Do you think it's independent of where you went to college? And a lot of people will say, well, sure it is. Maybe, maybe not. If you went to Oregon State, maybe you farm down here in the valley, in the Willamette Valley, and maybe if you're farming down here in the Willamette Valley, again, I'm just talking about just farmer types, because they probably want people to have tractors. They might have some more, John Deeres and New Hollands and things like this. If you went to Washington State, you're usually farming on the other side of the state, and you're not going to be using New Hollands a lot at all. Some John Deeres, but maybe more Caterpillars, maybe other things. And because of where you farm, because it's, usually you go to school kind of right where you live, okay? And so it's kind of an interesting thing to think about. So don't get all, well, of course it's independent. Maybe it is, maybe it's not. So here again, H naught is always, they are independent. They are. What is? Car brand and ice cream are independent of each other. Okay? And of course, they are dependent, or they are not independent. You can say it any way you want to. I don't care. Okay, so let's test this at 0.05 for an alpha. Okay, cool. Now, this is what we call a pivot table. If you've never used one, I will be putting up a video on how to do them later on. It's kind of fun. So we're going to drag brand of car here, brand of car here. Oh, look at that. It broke out all the cars by brands. Who saw that coming? And what did I say? Eye color? Boom. Nice. Nice. And so there they are. Before we go any further, though, what you want to do is you want to copy these guys, and then you want to paste them, some other sheet somewhere, but you want to paste them as values. This is very important. It's important to do it that way. Okay? So down here for my expected values, again, what I want to do, I want to copy these. Oops, well, I already had them copied, but I'm going to copy them again just for a good time. And I'm going to paste them again as values down here. And then I'm going to get rid of all this data inside. There we go. So here, how do we find that value? How do we find that value? Well, I'll tell you how we find it. We take equals the row, the column total, and we're going to hit F4 on our keypad until it hits 8 there, times this row total, we say, and we're going to hit F4 until it's in front of the F, divided by the grand total, and hit F4 one time. Hit enter, drag it down, drag it across. These, friends, are our expected values. So to find the differences, we're just going to go equals, and we're just going to click this one, observed, minus expected squared divided by expected. I'm going to drag it down 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And drag it across. We should be good to go. And then anywhere you want to equal sum of those values. And you get 20.55, which is crazy. So our degrees of freedom here is equal to, 1, 2, 3, 4, 5, 6 car brands, 6 minus 1, which is 5. And then 1, 2, 3, 4 eye colors, 4 minus 1 is 3. So 15 degrees of freedom. So here we're going to say equals 1 minus chi squared dist, there he is, this guy, comma 15, comma 1. So we get a p-value of 0.15. So what does that say? Well, we get a p of 0.15. In fact, what are we saying here? Oh, darn it. Darn it! 0.15. So what do? We fail to reject H naught. And what does that mean? It means, because I smudged up down here, it means in this case that car brand and eye color are independent, because that's what I did, right? Oh. Weird. Oh, look at that. I figured something out. What do you know about that? Alright, well, let's do another one. Let's find out. Let's go look at the data, because I can't remember what's in the data. Let's do gender and feelings about math. Yeah, let's do that. So somebody wants to know, is gender independent of feelings on math? By the way, never write it this way. That's sad. What you want to know is now you could say, is gender and feelings about math independent, or are they independent? But I would prefer is feeling about math independent of gender? And of course, if they're not, what does that mean? It means that one of them thinks differently about, math. So H naught, what? They're independent. H1, and of course, they're dependent. Okay? So it's very straightforward. We come back over here to the chart. Okay? Now you're like, wait a minute. But the book's going to give us data in a chart already. That's right. That's right. We'll deal with one of those in a second. Another one of those in a second, I should say. Oh, by the way, if this happens, nothing went away. Just click back on the table. There we go. Let's put gender in. Put gender in. Nice. Look at that. Look at that. Almost 50-50. Not quite. Almost. And what I want? Oh, feelings about math. Nice. So just grab this data. Let's copy it. Let's come over to another sheet somewhere. Let's paste special. Paste it as values. And then come down here and paste it again as values. And then just clean up this other oops, stop. Sorry. Let's clean up this other garbage in here. It's clear contents. And you can get rid of the grand totals. They're not important anymore. Okay? And so, keep in mind what we're saying here. Okay? We're saying that 106 out of 200, that's basically 53%. That's not basically, it's exactly 53% of the people are women. So 53% of these 18 ought to be women that think math is fun. But how we can do that is just simply click here, hit F4 twice, times, hit here, hit F4 3 times, divide by this guy once. By the way, if your F4 doesn't work, like on my Surface Pro, the F4 doesn't work right all the time, you can just go $4 and $E2 divided by $E $4. Type them in. Okay. So notice, of the 18 people who think math is fun, 9.5 of them should be women, 8.46 of them should be dudes. And we just drag it across. Okay? Notice how close we are to the actual values. Weird. Weird. It's almost as if someone planned it that way. What? No. Interestingly enough, what I did when I generated this data, I just generated random columns of data that had nothing to do with each other. So would I be shocked if they were dependent? I would be shocked because I didn't set it up that way. That is teeny tiny small, friends. I mean teeny tiny small. So column -1 is 2. Rho minus 1 is 1. 2 times 1 is 2. And so I'm just going to go equals 1 minus chi-squared dist. Boom. This guy, comma 2, comma 1. Shut up. There you go. There's a 96 for my p-value. What am I going to do? Fail to reject. Wow, what do you know about that? Boys and girls think similarly about math. That's what that test means to us. Okay? Alright, I'm going to do one more. Then I think I will have milked this pretty well. Let's do classes and feelings about math. In other words, would it shock you to find that people in different classes think differently about math? That wouldn't shock me at all. If you're in pre-calculus, you probably like math. If you're in Algebra 1, it's a good bet you probably don't. At least in high school, let's put it that way, right? So, is feeling about math... Well, this is the question, I should say. This is the question. So the question is feeling. So, feeling about math independent of class, and of course, feeling about math dependent on what class you're in. Okay? And again, let's just keep with the theme of 0.05 for our alpha value. So I already have this pivot table set up. We'll just click on these guys and you can just drag them out. But we'll leave feeling about math. Let's put feeling about math on the count as well. That's key. And then let's drag in the class. Boom. Okay? So if you look at that, it's interesting. A lot of people hate math. Yeah, maybe in this case it's not important. Notice I only went Algebra 1 to geometry, to Algebra 2. Okay? Had I gone on to calculus and stuff, I might have found a different response, which wouldn't shock me a great deal because, well, it makes sense. I mean, kids keep taking math because they like it as a general rule. Not always, but sometimes. You always get the kids that are like, I'm only taking this because my mom's making me. Oh, that's fun. Okay. So to get our expected values, it's equals this guy, F4 a couple of times, times this guy, F4 3 times, yes, divided by this one time. If you don't lock those in when you drag them down and sideways, things are going to get nuts. I think it's always a good idea to double check. Is that the right thing? Yes, it's the right row and the right columns. That's awesome. And so then my values will be equal to observed, I say, minus expected squared divided by expected. No way. Who saw that coming? Wow, there's hardly any of them that are very big. And you're, I know. So, highlight them all. 3.57. There's 3 classes. 3 minus 1 is 2. There's 3 feelings. 3 minus 1 is 2. 2 times 2 is 4 degrees of freedom. So, equals 1 minus chi-squared dist of this guy, comma 4, comma 1. And you get a 0.46 for a p-value. So what does that mean to me? I'll tell you what it means to me. It means fail to reject. It means fail to reject, and there is math feelings are independent of class. And again, that's one where a person might have thought going into it, oh, yeah, of course it's dependent. Of course it matters. Well, sometimes it does. Now again, here's the data. This is how your book will give it to you. Just be aware of that. I will be sending out an assignment, I believe, later on where I actually give you a pivot table, kind of like this data over here. and ask you some questions regarding that. That and on the test that might show up as well. Because I think this to me is more like it. I will have gathered a bazillion pile of data, and I'm trying to see if I can come up with any sort of relationship there. And so one of the relationships might be a dependence situation. And, maybe you subscribe to the idea that, well, Jay, the only reason that kids are doing bad in your class is because it's not fun. They just don't like it. They just don't see like math is fun, which sometimes it is and sometimes it isn't, boss. Leave me alone. But, it could be a situation like that. It could be a deal where, sometimes maybe it's a situation where maybe you've gone so overboard that now the boys are thinking it's not very fun because there's always women in this and women in STEM and women in this thing. Maybe we've gone overboard. Back in the 60s and 70s, maybe it was the other way around. And who knows? There could be a variety of reasons. But if people are feeling a certain way, or they're finding themselves in this box versus this box, and it has to do with where they're at, is there something we can do about it? It always comes down to statistics, and that's why I love it. It comes down to making a decision. Okay. And again, here's one where you could break it out by, the goodness of fit test actually is used sometimes to see about when people do arrests based on, race. And so in a particular part of town, the particular racial makeup of that part of town is whatever percent, whatever percent, whatever percent. And then the arrests are, this other thing, and you're like, oh my God, that's terrible. Well, then the question then is not so much as, well, yeah, it doesn't fit the percentage of the population, but not only does that, if that was the end of the story, then obviously we have a problem. But then the question might be, well, what else can we do with that? Again, statistics is all about answering questions. Sometimes asking questions too, but answering questions, making a decision. That's the whole point. Okay? So again, if I've got some kids that are feeling like, hey, math isn't fun, or math's boring, or math has no importance to my life or something, well, and maybe it's more girls than boys or vice versa, or maybe it's more in the lower sections than the upper sections or whatever. What can I do as a teacher to try to make that better for them? Okay? So again, that's the whole point of these things. If we find some weird relationship, it comes down to what can we do to make it better? There is another one that I just want to throw out real quick, and it happens sometimes. But what if you had a cold? And that's a straight line in case you're wondering. So, I don't know, sick. Let's see, how do I want to put that out there? So, let's see, so go away. I'm just trying to put up one here that would make sense to you, maybe. What I was trying to say is this: if you looked at, the drug or the placebo, nice, and these people are still sick, and these people are well, and it's 3 and 20, and it's 10, because it is the common cold after all, right? And some people just get better. That's just how it goes. But if you think about it, there's 13 people that were sick, that are still sick, and there's 30 people that are not sick, for a grand total of 43. Of course, there's 20 here and 23 here. Okay? Well, 13 out of 43 is, I need a calculator. You hippie. So 30% are still sick, 70% are better, yes? Makes sense? So of the 23 people that got the drug, I would expect 30% to still be sick, you see? I would expect 6.9 of them to still be sick. And the rest of the 23, which would be 16.1, I think, I would expect to have gotten well. And of course, 30% of 20 is 6, and then 14. All right. Now, what are we testing here? We're testing to see if getting well is independent of the drug. Well, I hope not. That's the whole point of the drug, right? So the whole point is if the drug works, then getting well should depend on the drug. Or the treatment, I guess, if you want to think of it that way. And so, clearly, it's going to be 3 minus 6.9 squared divided by 6.9. And, of course, it's going to be the observed minus the expected squared divided by the 6. And then it's going to be 20 minus 16.1 divided by 16.1. And then, of course, it's going to be 10 minus 14 divided by 14. Of course, this is squared, as is that. And what you're going to find is that this is going to be a giant chi-square with 1 degree of freedom. And you're going to reject H naught. And what happens? Oh my God, look at that. It depends on whether I get the drug or not. Who saw that coming? But if in a study it literally came out something like this, if when you did the study, your drug came out like your new wonder drug, if your new wonder drug came out something like this, oops. Alright, let's try it again. I'm getting tired. Been drawing all day. There we go. 19, 21, 18, 22, whatever. Basically, this is 40. And this is 40. Huh! This is 43, and this is 37. Again, for a grand total of 80. Who saw that coming? And here's my point. Look at this. It's almost 50-50 in both cases. Meaning it's independent. You get better whether or not you take the drug or not. So the drug, well, sucks. And that's because getting better is independent of whether you take the drug or not. This is another place where this actual test comes into play, is in a situation like that.